Welcome to qnawire.
To solve this question, we have to be quite smart about the physics of the problem. Newton's second law tells us that the net force that acts on an object is given by the mass of that object times its acceleration. So, the net force is responsible for accelerating that body. Keep that in mind. In this question, we have three bars that are coupling the cars. So, let me say that we have a tension here in bar A. This is tension A. We have a tension here in bar B. This is tension B. And we have here a tension C in bar C. Of course, there are the reaction forces of those tensions. They are like this. This is TA. This is TB. And this is TC. So in this diagram, in red are the forces, the actions, and in orange are the reactions. We will care particularly about the actions. Notice the following. This force, TA, is what is making everything move. So TA is responsible for making car 1, 2, and 3 move. Then we can say that, supposing that my reference frame points to the right, we can say that TA is given by the mass of car 1, 2, and 3 times the acceleration of the system. This is because TA is responsible for moving the objects 1, 2, and 3. We can do the same for TB, because the tension B is responsible for moving cars 2 and 3. Then, tension B is given by the mass of the second car plus the mass of the third car times the acceleration of the system. And finally, TC is responsible for moving the last car. Therefore, TC is given by M3 times A. And notice that I have used the same acceleration for every car. This is because they are moving together, so they have the same acceleration, which is 0.12 meters per second squared. Knowing this, we can proceed to the question. So in all items, we are removing 39 kilograms from car 2. But in the first item, we are removing from car 2 and transferring to car number 1. How does the tension changes among the cables? So the tension A is now given by M1 plus delta M1, because we are adding more mass to car number 1, plus M2 plus delta M2, because we had removed some mass from car 2, plus M3. M3 do not change. This is times the acceleration. Notice that delta M1 is equals to plus 39 kilograms. We are removing 39 kilograms from car 2 and adding 39 kilograms to car 1. And then you can notice that there is a cancellation, because delta M1 is equals to minus delta M2. As a result, TA prime is just M1 plus M2 plus M3 times A. So it's the same. Therefore, the tension in cable A do not change. Now, for the cable B, we have M2 plus delta M2 plus M3 times A. And then this is M2 minus 39 plus M3 times A. You can see that this is smaller than tension B before removing that luggage. Then we can calculate what is the difference between the original tension and the tension right now. So the variation in the tension B is given by the tension B now minus the tension B before. And it is M2 plus delta M2 plus M3 times A minus M2 plus M3 times A. You can see that a lot of terms will cancel. So M2 times A will cancel and M3 times A will also cancel. So we are left with delta M times A. So the change in tension B is given by delta M2 times A. And this is minus 39 times 0.12, which is approximately 4.7 newtons. And then we can calculate what is the tension C after moving the luggage. The tension C is given by M3 times A, and it does not change because we are not messing with the mass of car number 3. So summarizing, we have TA being equal than it was before, TB decreasing by 4.7 newtons, there was a minus sign here, and finally TC being equal than it was before. Let me organize my board so I can continue solving this question. In the next item, what we do is that instead of moving the luggage to car number 1, we move the luggage to car number 3. So B, we move it to car number 3. Then delta M3 is equal to 39 kilograms. Let's see what happens to the tensions. The tension in cable A after is given by M1 plus M2 plus delta M2 plus M3 plus delta M3 times A. You can see that there is a cancellation between M2 and M3, so we got the same tension as we had before. So the tension in cable A doesn't change again. The tension in cable B is given by M2 plus delta M2 plus M3 plus delta M3. Again, we have the cancellation between delta M2 and delta M3. So the tension is the same again as it was before. And finally, we have the tension C, which now is given by M3 plus delta M3 times A. You can see that this is bigger than the tension C before moving the luggage. We can then calculate what is the variation in tension C. This is Tc prime minus Tc, which is M3 plus delta M3 times A minus M3 times A. There is a cancellation that happens between M3 and A and M3 and A, and we are left with delta Tc being equals to delta M3 times A, which is 39 times 0.12. And this results in 4.7 newtons. Then we summarize the answer for the second item as the tension A is the same, the tension B is the same, and only tension C changes, and it changes by 4.7 newtons. And this is the answer to the question.